Hello everyone, today we are going to solve the problem even number addict from Codeforces Global Round 22. In this problem, it is given Alice and Bob are playing a game on a sequence A1, A2, AN of length n. They move in turns and Alice moves first. In the turn of each player, he or she should select an integer and remove it from the sequence. The game ends when there is no integer left in the sequence. So suppose there is 5 element A1, A2, A3, A4, A5, and in the first turn Alice remove A3. So element 3 will be removed by Alice. Then it is Bob turn and Bob removed A4. So element 4 is removed by Bob. Then suppose Alice removed A1. Then element 1 is removed by Alice. Then Bob removed A5. Element 5 is removed by Bob. And in the last turn, Alice removed A2. So element 2 is removed by Alice. Then they said Alice wins if the sum of her selected integer is even, otherwise Bob wins. Your task is determine who will win the game if both play optimally. So let's say the element 1 was 2, 5, 1, 3, 2. So Alice removed 3, is 1, and then element 1, 2, then element 2, 5. The summation of 2, 5 and 1 is 8. So 8 is even. So here Alice wins. If this element was 2, then the sum would become 9 and 9 is odd. So in that case Bob wins. So here the n and the array is given. We have to determine the winner. Let's solve one test case. Let's solve this one. 4, 1, 3, 5, 7. So suppose in the first move Alice chose 5. In the second move Bob chose 3. Now in the third move, if Alice chose 7, the sum is 12. If Alice chose 1, the sum is 6. So anyway, Alice wins here. That's why the result is Alice. Now let's see this test case. 4, 1, 2, 3, 4. If Alice chose 4, then Bob will choose 2 here. Then when Alice's turn comes, there is only left elements is 3 and 1. If Alice chose 3, the sum becomes 7. If Alice choose 1, the sum becomes 4. So in both cases, the sum is odd. So Alice can't win. Basically, Bob wins here. So this was the question. Now let's see how can we solve this. So if there is n element, like 6 element, so Alice can move. So Alice have 3 move, right? And Bob has 3 move. And if n is 7, so Alice have 4 moves and Bob have 3 moves. So if n is even, so Alice can have n by 2 move, right? And if n is odd, Alice can have n by 2 plus 1 move. So this is fixed. Now let's say Alice have 4 moves. Now what are the ways that Alice can have an even sum? Number 1 is 4 even number. Right? 4 even numbers can make a even sum, or 2 even, 2 odd, or 0 even, 4 odd numbers. Now this was the only observation you have to make in this problem. So if Alice have x move, he should have x even number, or x minus 2 even number, 2 odd number, or x minus 4 even number, 4 odd number. Like this, 0 even number, x odd number. If Alice can get any one of this, he can make an even sum from any of this configuration. So in that case, Alice wins. Now suppose Alice need 3 even and 2 odd number. If these are the all array element and Alice need 3 even number from this element, then what should be the minimum number of even numbers in this array? Suppose these are the 3 even numbers. Now in first move, Alice will take this 4, but in second move, Bob will take this 2, and in third move, Alice will take this 6. So Alice will not be able to take this all 3 even number in his first 3 moves. So what if there was another even number, let's say 2 here. Now let's see what's happened. Now suppose first Alice take this 4 and Bob takes this 2. Then Alice take this 4 and Bob take this 2. Now there is no even number left. Alice got only 2 even number here. So 4 even number is also not working. Let's say there is another even number here is 4. Now first Alice will take this 4, Bob will take this 2, then Alice will take, let's say, this 4, Bob will take this 6, and Alice will take this 2. In that case, Alice will get his all 3 even number here. So what we observed from that? If Alice need x even number, then there should be x minus 1 even number from Bob also. Means if Alice need 3 even numbers, then there should be 3 minus 1, 2 even number for Bob also. In that case, Alice will able to take this all 3 even number. Now 2 odd number are left. Let's see this. Here first Alice, let's see these are odd number, 1 3 1 3 1. Okay, so first Alice took this number, Bob took this number, then Alice took this, Bob took this, then Alice took this number. So that's how he got his 3 numbers. Now this is Bob turns. Bob will take this 1, Alice will take this 3, Bob will take this 1, Alice will take this 3. So if Alice need 2 odd number, there should be 2 more odd number also, right? So if Bob need y odd number, there should be y odd number also for the other player. So total even number needed is x plus x minus 1, and total odd number needed is y plus y. So we will iterate those one by one and any one of these satisfy these two conditions, then Alice will win, and otherwise Bob will win. So let's see the code. So this is the n number of element, this is the array. Now here I took a variable move. This is the move number of move for Alice. If n is odd, then move plus plus. Okay, as we have to iterate from for every move, like first x is move, then x minus 2 means move minus 2, then move minus 4, like this. That's why I took here an temporary variable now, from which I will minus 2 every time. Then there's two variable even and odd, and this is the count of even number and odd number in this array. So while one, I am explaining this later. Let's see this part. Here now is the number of move, right? So val1 is now plus now minus 1. Why? This is actually this part, x plus x minus 1, actually this now plus now minus 1, and variable 2 is move minus now. Now this move minus now will give us this odd part, right? Suppose now suppose the total move is 5 and now is 3. That means he need 3 even, and 5 minus 3 equal to 2 odd. So this 5 minus 3 is move minus now. So this is move minus now. I'm sorry, this move minus now plus move minus now. This part is this y plus y part. I explained here why y plus y is needed. This is this part. Move minus now is 1y, and this move minus now is another y. Now this x plus x minus 1 is the count of even, right? So even should be greater than or equal value 1, and odd should be greater than or equal value 2. This y is the count of odd in this array. So if this condition is true, then I will print Alice and make my flag 1, and when f flag is 1, I will break from this while loop. Now this part is same as the previous part. The difference is only here I took the even part first and odd part secondly, but there can also a case where you have to take this odd part first and even part later from this array. So this is exactly same like this code. I take the even part here and odd part here. Okay, and here I am subtracting 2 each time. What I explained here, I have to subtract 2 from every time. Now when I will stop, when my x become less than 0, that time I have to stop. That means Alice can't have any even number now. So that's why if now is less than 0, so in that case Alice can't win now, so Bob wins, and then f is equal to 1. If f is 1, break. That's how I'm ending my while loop. I hope you understood the problem. Here is the complete solution. I will provide the link of this code in the description. Thank you.